So let's understand the concept of boundary layer formation, because that's very important to clarify some subtle differences. When I said the motion is allowed or it's not allowed, that may bring you some problem, because bulk fluid motion can be allowed or not allowed. Otherwise, the fluid motion is always allowed. That's the only way we will have some diffusion kind of heat transfer. So that will be more clear when we understand the free or natural and forced convection. So that small difference will clarify when I say yes and no both, right? But let's right now understand the boundary layer formation. So what is a boundary layer and how does it form? So if we have a surface, solid body surface, which is starting from here. So this is x is equal to 0 point, and let's have some x point over here. So over here, and a fluid is coming. When I draw it like this, it means that the fluid has a uniform velocity u, or u infinity. And when we are understanding it with respect to heat transfer, let it also have a temperature T infinity. So that was what I said or had a reference when we are using the Newton's law of cooling also. The T infinity was the temperature far upstream from the surface, So over here, and this is y is equal to 0, and as we go up, the y value increases. At this point, when the fluid molecules interact with this surface point, the u value becomes 0. That is when x is equal to 0 and y is equal to 0. Far upstream from x, at this point the u value will be as it is, somewhat as it is. It may not be exactly u infinity, but it will be less affected because of this surface. The velocity of the molecules which are close to the surface will be more affected because of the viscous force. Which are the force? It is viscous force, viscous shear forces, right? So a velocity profile which is uniform like this will change to a velocity profile which is slightly parabolic. So at this point the velocity is 0, and as we go upstream away from the surface, the velocity keeps increasing, and at some point at some height the u infinity is as it is. And so this was the velocity profile. So now let's look at the temperature profile. Before, the temperature was also uniform, but now let's look at the temperature profile also. So at the surface, let's assume the surface temperature was Ts, which was greater than T infinity. So that means my heat will be transferred from the surface to the fluid. So the surface temperature is Ts, which is higher than T infinity, and as we go away from it, the temperature is T infinity. So this T infinity doesn't have any arrow, it is a scalar value. So this is close to Ts and this is close to T infinity. So that's how. So this is also slightly parabolic, but exact equation of this line will derive later. So this is temperature profile. So in absence of bulk fluid motion, if this bulk fluid motion was not happening, so in absence of bulk fluid motion, the heat transfer is always due to conduction. So if we want convection to happen, that bulk fluid motion must happen. That must occur for bulk fluid motion must occur for convection to take place. So one thing important is, why did we do this? Why did we assign a velocity of 0 when it touched the surface, or when we are at the surface? This x is equal to 0, y is equal to 0 means we are at the surface. That means we are following no slip condition, and that is due to this viscous forces, right? And so we have viscous boundary layer, what is this? This is, so over here we can see that my velocity u infinity is attained at a height of, maybe let's say this is some height y, and as we go away, that y height will increase and it will then get constant after some distance on x. So after some distance it will get constant. So this profile which we see is the boundary layer, viscous boundary layer. And so that's all. That was the concept of boundary layer formation. We'll go into more details, and there are a lot of derivations which are related to this boundary layer formation and what kind of flow it is, turbulence, laminar flow, intermediate flow, and there are a lot of different things. So we'll not go into details right now. This was just a small introduction for you. The main thing we'll go into is the convection and its two forms, the free and or the natural convection and the forced convection, in the next video. Okay.